Okay, in this video we're going to take a look at solving exponential equations. Now I view these problems as coming in three type of varieties. So we're going to look at variety 1. In variety 1, you have no need for a calculator. Okay, all the solving can be done using our knowledge of exponents. So let's look at one example. 2 to the x equals 8. Now this can be handled just by drawing upon prior knowledge. You may know, and you may just know that 2 to the 3 equals 8, so x must be 3. So prior knowledge is key. Another way you can think about it is you might rewrite 8 as 2 to the 3, since 8 is 2 times 2 times 2. And here, the answer is staring you in the face, because if 2 to the x equals 2 to the 3, clearly that means that x equals 3. Okay. Let's look at another situation. We can get a little more difficult. We could start dealing with fractions as our base. Okay, but really it's the same. It's the same process. You just need to remember some rules of exponents. Like for instance, 16 is 4 squared. So again, I can write this as 1 over 4 squared to the x. And now that equals 4 to the 3. But 1 over 4 squared, if you remember, is the same as 4 to the negative 2. So now that's 4 to the negative 2 to the x. And then another rule of exponent allows us to multiply the negative 2 with the x. So I get 4 to the negative 2 x equals 4 to the 3. And since I have the same basis here, I can, of course, set the exponents equal to each other. And I can go solve. Negative 2x equals 3, which means that x equals negative 3 halves. Okay? And I guess one more version of this variety might be something like 9 to the x plus 1 equals 3 to the 4x plus 5. Slightly more difficult, but again, if we can get the bases the same, we can set the exponents equal. So my base on the left is 9, but I can rewrite 9 as 3 squared. So I can write this as 3 squared to the x plus 1. Notice I kept that 3 squared in the parentheses. And that equals 3 to the 4x plus 5. And now it's important, this next step confuses a lot of students. This 2 interacts with the x plus 1 by multiplying, but you have to remember to distribute. So it's 3 to the 2x plus 2 equals 3 to 4x plus 5. And now I've got the base is the same, so I can set the exponents equal. And I can go off to the side and do the algebra. And we get x equals negative 3 halves. That's a complete coincidence when compared to the last problem. Okay, so there's variety 1. Variety 2 is slightly different in the sense that you've got something like this. 2 to the x equals 7. Now the reason this is slightly more difficult is because, well, 7 is not a power of 2, like 8 is above in example 1a. So, I mean, the best I can do without a calculator is sort of estimate, because, for instance, I know that 2 squared equals 4, and I know that 2 cubed equals 8. So it's like 2 is too small and 3 is too big. So I'm guessing that x is somewhere in between 2 and 3, maybe like 2.7 or something like that, 2.8. Okay, but in order to get an exact answer, we've got to use logs. Okay, because there's one really important property of logs which allows us to get that exponent down. Okay, we want that exponent to come down. So what you can do is you take the log of both sides. One thing to keep in mind about equations is almost in general, as long as you do the same thing to both sides of an equation, it's not going to change the values of the variables. So if I take the log of both sides, this becomes log of 2 to the x equals log of 7. And here's the key property of logs. This 2 can move into the front. So it becomes x log 2 equals log 7. And then I can divide by log 2. And I get my answer. X equals log 7 divided by log 2. And you punch that in your calculator and you get 2.807. There's X. Okay, so there's variety 2. What about variety 3? Variety 3 is basically like variety 2, but it's kind of like upping the ante and throwing at you everything you've sort of come across in your math solving experiences all at once. So you get something like this. Students freak out. Okay, they find it very confusing. It's very hard to do by guessing check, because I don't know about you, but I can't think of the x value that's going to make this true off the top of my head. Unlike in variety 1a, where you kind of you knew the answer was 3. Okay, so we've got to solve this. Now the first goal is to get this exponential part that I'm circling now by itself. We need to do that, because once you do that, you essentially turn a variety 3 problem into a variety 2 problem, which we know how to solve. So, how do we do that? Well, we have to get rid of the 6 first, and that gives me 4 times 1/3 to the x minus 2 equals 5. Okay, I'm going to move over here. I'm running out of some space. I'm going to copy this again. Okay, again, the goal is to get this guy by itself. What's happening to it? It's being multiplied by 4. We undo that by dividing by 4. So now I have 1/3 to the x minus 2 equals 5/4. And so we've done it. We've gotten the exponential piece by itself. Now is when we got to take the log of both sides to allow us to use that property, which will bring that x minus 2 down. If you don't remember the properties, Miss Adams made a really nice video. If you go to my website, Get Ready for Advanced Math, the video, she does a whole section on logs properties. So that x minus 2 can move down, and when we move up here, what we get is x minus 2, parentheses, right? That whole thing is being multiplied by log of 1/3, and that equals log of 5/4. Now our goal is to solve for x, so we're going to divide by log of 1/3 to get that out of there. And now I have x minus 2 equals log of 5/4 divided by log of 1/3. And at this point you can punch that into the calculator and then add 2 to both sides, or you can add 2 now and punch it all into the calculator at once. But in any event, we got to add 2 at some point. So I'll just add it in there. And when you punch it into the calculator, after all is said and done, I believe you get 1.6 7, 9, 7. Okay, there is variety 3. More complicated, but really only more complicated because you have to isolate that 1/3 to the x minus 2 first. Okay, I think there's many places for misconception, so find the place that you don't understand. If you don't, star it or something, and if you want to ask me about it, feel free tomorrow.